Now I'd like to introduce our speaker today, Nathan Deutsch. In his role as the M&P Department Manager at ADF Engineering, Nathan leads a team of skilled process and mechanical engineers driving significant improvements in process safety and efficiency. His contributions have been widely recognized, earning him accolades such as the ADF Engineering Excellence Award. Additionally, Nathan's certification from the P&G Process Safety School underscores his commitment to maintaining exemplary standards in process safety. So with that, I would like to turn it over to Nathan for today's presentation.
All right. Yeah, thanks, Tim. Gonna get right into this. So the agenda today is, going over some various overpressure protection devices. It's not an all-inclusive list, but this is the vast majority of types is what we'll cover. We're going to go over, when are they typically required, various scenarios that you should consider in selection and sizing, and then, often what's needed for sizing, and then a few tools that are helpful that are, free and available for sizing and selection, and then briefly touch on maintenance and testing requirements as well. So most of you are probably familiar or have seen some of these devices before, but the general terms for overprotection or overpressure protection devices include pressure relief valves, which is that device shown in blue there as an example, rupture discs, breather vents, or also can be referred to as pressure vacuum valves or emergency vents. There's a variety of terms for them. That's kind of what that silver device looks like there. I'm going to briefly touch on rupture pin valves as well, which a lot of people have not heard of and are pretty rare, but they do have kind of niche cases that they're used. One important distinction with overpressure protection is I'm talking about, sources of pressure from the process or fire or upset conditions. I'm not talking about explosion protection, although some of those devices can look the same. Those are totally different, separate requirements and different sizing needed for explosion protection, and that'll be covered probably on a different topic on a different day. So getting right in, pressure relief valves here. I've got a kind of a cutaway of a typical pressure relief valve. If you squint, you might be able to see it. And then one that's kind of installed in the field. So they are spring operated. They work via the process fluid or liquid or device in there, pushing up through an orifice and then escaping out of the valve on a 90-degree angle typically. They're most commonly seen in ASME 1 and ASME 8 applications. ASME 1 would be boilers, and ASME 8 is pressure vessels above 15 psi. Nice feature about relief valves and why one of the reasons they're so popular for overpressure protection is that they will, reseat after a relieving event. So they will seal back again after they go off once the pressure goes away. So that is one nice feature. But they do require maintenance and testing. I mean, there's moving parts in there. They don't require power, but they do have a moving spring, right? That's precisely machined and set to lift at a specific force below, or if it's a vacuum, the other direction. But they do require maintenance and testing. So that's one of the downsizes. One important distinction about relief valves is that a lot of people, are looking for sizes that match the pipe they're on, or maybe don't understand how they're sized, but the governing criteria for a relief valve is the orifice diameter inside. And there are very specific orifice sizes that are published by ASME and API that govern, the various orifice sizes, and those directly correlate to relieving capacities. So when you're sizing a relief device, you're really sizing that orifice, and that's what's doing the relieving. And the process connections, the sizes are a result of that orifice. And so, oftentimes a particular orifice size will have a typical inlet and outlet size, but it's not always the case. And there are some variety in that. So, if you're looking for a 3-inch relief valve, what you're actually looking for is the orifice that would maybe be aligned with those typical process connections. So I think that's an important distinction. Next, rupture discs. So these are, they don't stand out as much because the actual device is quite small, but they are typically a thin round disc of metal, and graphite can also be used, that are precisely machined to a certain thickness to rupture at a specific pressure. They also are used commonly in ASME 8 and 1 applications.